Asynchronous streams allow us to work with streams of data. No matter if the data is coming from the web, a database, or disk, or any other type of asynchronous operation. The idea is that we can process items as they are arriving to the application in a better and more intuitive manner. Let's jump into Visual Studio and have a look at what this looks like.
Asynchronous streams requires the project to target .NET Core 3.0 or later. What we'd like to do is present the stock information in the application as it arrives. We saw one way of doing this earlier, but it's time to introduce a more readable and maintainable alternative. This application will now work with a local file again to stream the stock information that it loads. Instead of having to wait for all the stocks to be loaded, I now want to display each line of the stock price as the application gets a hold of that data. Let's start off by introducing an interface that will allow us to introduce different implementations of this stock streaming service. I've already created this new file called stock stream service, and it's available in the exercise files. Inside this file, there's an interface called the iStockStream service. This defines our contract. This contract tells us that we need to implement a method called getAllStockPrices. GetAllStockPrices returns an iAsync enumerable of stock price. This is new and not something that we've seen previously. The iAsync enumerable allows us to define that we now have an asynchronous enumeration. Whoever is consuming the iAsync enumerable can use it, retrieve, and work with each item as they're available to process. Let's create a first implementation of this streaming service. We'll start off by creating a mocked version, which will allow us to understand how all of this works. We can now proceed to implement the method defined by the interface. The goal is to return a few different stock prices, and we want to fake that we've received these asynchronously. Mark the method as async so that we can introduce a few delays that simulates loading some data. You'll notice that we don't need to return a task. The compiler doesn't complain about the fact that the return type is an iAsync enumerable. We can use the async keyword together with the iAsync enumerable in order for us to indicate that we want to introduce an asynchronous enumeration. This now gives the method the capability to use the await keyword. We use it to simulate that it takes a little bit of time to load some data that is then returned back to the caller. Normally, when we return a value, we simply use the return keyword. But since we are now setting up an enumeration, we need to introduce something else as well. We need to add the yield keyword to indicate that we now have an item available to process. To make it a little bit more interesting, let's return a few values. Each stock price from this mocked service will take approximately 500 milliseconds to retrieve, and when it's available, we'll notify the iterator that it can now process the item. What's really interesting here is that we now use the async keyword, the await keyword, the iAsync enumerable, as well as the yield keyword, in order for us to create an asynchronous stream of stock prices. To summarize what this method achieves is that it fakes that it takes about 500 milliseconds to retrieve an item. Once that's retrieved, we then indicate to the iterator that we have an item available for it to process. Then it goes ahead and retrieves the next item, which also takes approximately 500 milliseconds, and then it continues doing the same for the rest of the items. This produces a stream of data. Now, all that we need is a way for us to use this in the application. Let's jump over to the main window class and consume a stream of data. To use an asynchronous stream, the method that consumes it needs to be marked as async, as well as somewhere in the method use the await keyword. To dynamically add items to the UI as they arrive to the application, we are first going to introduce what's called an observable collection. The data grid will then use this as its items source, and as items are added to it, they will appear in the UI. Now, how do we consume the stream of data? What we've done previously is using the await keyword in front of the asynchronous method that returns a task. In this case, it's a little bit different because we are now returning an enumeration that will asynchronously allow you to retrieve items. Instead of having the await keyword in front of the method call, we're going to use the await keyword in front of the for each loop, where the for each loop will then make sure that it's properly awaiting each item in the enumeration. We've now introduced a for each loop, where each item in the collection will asynchronously be delivered to the for each loop, which means that the body of the for each loop is a continuation. We could now check if it's the stock we're looking for and then add this to our collection. Now that we run the application, you'll see that as soon as we retrieve an item, we're going to have that added to the data grid. The for each loop will asynchronously retrieve each item. How about replacing the mocked implementation with something that uses the file system? As you process each line in this file, you want to return that to the caller. We can introduce a new class called stock_disk_stream_service, which will implement the interface iStockStream_service. It's going to read each line in the stock file, process that, and then return it back to the caller. The caller can then take care of either processing the element or just request the next element to be loaded. The implementation of this method is going to be very similar to the one that we had earlier in the course. There are, of course, going to be a few small changes. First, open a stream to a file on disk and process each line asynchronously. Skip the first line because that's the header row, and then we're going to iterate over the rest of the lines. Let's make sure that we also check if a cancellation has been requested. If we requested to cancel this operation, we're simply going to break out of the loop, and we can then just return back to the caller. It's best to handle this and cancel gracefully. Once we've got an instance of a stock price parsed from the comma-separated values, we can use yield return to let the consumer of the asynchronous enumerable know that there is now a new item to process. This means the item will be returned to the for each loop for it to process. We didn't, in fact, add any fake delays or anything like that to this method. What we're doing is scanning a potentially large file and returning an object back to the caller for it to process as soon as it's available and loaded into the application. We can now go back to search click and change this to use the stock disk stream service. As you run the application and search for stocks, you'll notice that it fills up the UI as soon as the items are loaded and parsed. We didn't have to wait for the entire file to be processed before returning anything back to the application. Not only does this open a whole lot of different possibilities for us when building our applications, the code is also much more readable and easier to maintain. If we compare the current state of the application to what we had earlier in the course, the user experience is a lot better, and that's partially thanks to the asynchronous streams. In cases like this, where we are scanning through files looking for certain records, using the asynchronous streams is beneficial. We can communicate back to the UI as soon as we have data available. That's going to provide a better user experience. The asynchronous streams allow you to asynchronously retrieve items. Consuming an asynchronous stream is as simple as adding the await keyword in front of a for each loop. To produce an asynchronous stream, you use the async keyword together with an iasync enumerable, the await keyword, as well as the yield return. This is a powerful addition to the language and provides a better way of expressing yourself. Although, without understanding tasks and the async and await keywords, this would have been a lot harder to grasp. C# also introduces the concept of an asynchronous disposable. If a class implements the interface iasync disposable, you can await the using statement that will dispose of the object. The syntax for this looks very similar to the asynchronous stream. With the for each loop, you simply add the await keyword in front of using. This can also be used together with using declarations. This may look odd if you haven't seen the using declarations before. This will ensure that the resource is disposed at the end of the method. As you then await it, the asynchronous disposable will also be validated. These two additions makes a great addition to asynchronous programming in C#.